Welcome everybody to this I3h seminar. We are very excited to have Professor Guilhem CASSAN with us today. Guilhem is a professor at the University of Namur. If you Google his webpage, you will find that he's extremely active in many different institutions, at CEPREMAP in Paris, at CEPR in London, at CAGE in Warwick. He's also a fellow of the World Inequality Database. And he is also actually a visiting fellow at I3h here at the University of Brussels. So he's extremely impressive. He's been working on many different topics, including development, healthcare, and public goods in public economics in general. And today he will give us a presentation about how discrimination against women in the world may affect fertility. So Guilhem, the floor is yours, about an hour 15, plus time for questions, so that we have about an hour and a half altogether. Welcome, and go ahead.
Okay, so thank you very much for having me here. I'm very excited to be here. I really like this idea of I3h to combine basically this multidisciplinary approach to health issues. So I'm very much looking forward to your comments. So this specific project that I'm presenting is joint with Jean-Marie Balland and François Vautrin. Jean-Marie is a colleague at the University of Namur, and François Vautrin is a PhD student with us in Namur. And the project we are working on relates to, as Michael was saying, gender discrimination and how gender discrimination affects fertility practices. So this is a health institute. So why should we think of this as health, and why, as an economist, are we interested in those types of questions? In economics, in the tradition of the type of economics that I'm doing, we tend to consider that what is economics is basically what allows people to fulfill themselves. And so this includes many things, such as education and, of course, health. And so as economists, we consider that health is part of our domain of interest. And in that specific case, we're looking at how women in general, but we see not only women, but the fact that there is gender discrimination may lead women, girls, to not be able to even be born, to be treated differently, to be facing discrimination, and this discrimination leading to excess mortality. So there is really widespread gender discrimination in the world. In general, this gender discrimination, in the vast majority, is towards a preference for sons, so girls are discriminated against. It's not always the case, but really it's the absolute majority. So why is that the case? So this has been studied extensively by sociologists, by anthropologists, and by economists as well. So there are cultural practices that make families tend to prefer to have sons. So for example, patrilocality, which is that when there is a marriage, the wife will move in the village of the family of the husband. So in that sense, she's lost from the perspective of her family. It could be the case that it's sons that are supposed to give old age support. In many societies, there are dowries. So when your daughter is getting married, you have to pay for that marriage, huge dowries. And having a daughter is therefore a cost compared to having a son. And so those cultural practices lead to widespread preference for sons. And so this preference for sons leads to discrimination and change in fertility practices and excess mortality of girls. So this has been widely documented. For example, Amartya Sen in the early 90s came up with this concept of missing women, which is those number of women that would have been alive had they been treated as men are treated. And so Anderson and Ray in 2010 make an evaluation of how many women are missing, and just for that year 2000, they estimate that 5 million women have died that year that should not, had they been treated as men are treated. So we're looking at one specific dimension of this gender discrimination, which is gender discrimination in fertility practices, or how these gender preferences affect fertility practices. And one thing that we're interested in is the fact that when there is preference for a gender, so preference for sons, parents will want to have more sons than daughters. And so this can have typically two types of consequences in terms of fertility practices. One is called the stopping rule. And the stopping rule, what is it? It's basically if you want a certain number of sons, you will continue to have children until you reach the number of sons that you want. Okay, so that's the stopping rule. That's one thing. Another type of fertility practices is sex-selective abortion, which is that when you have the technology to identify the gender of the fetus when the wife is pregnant, you can select to abort if the gender of, you can choose to abort if the gender of that fetus is a woman rather than a man. And so this leads to abortion that is conditional on the gender of the child to be born, sex-selective abortion. So those are the two practices, fertility practices that are directly linked to gender preferences, to the fact that parents in many societies want to have more sons than daughters.
But you can also let daughters die.
That's also what you can do that, but then that's not a fertility practice. No. That's directly that's discrimination conditional on already being born.
But they will, in the data, they would not be declared as being born, so you would.
Okay. So that's
them as being.
So yeah. Okay. So then there is it's possible. So there is also, as you say, different. You will treat differently sons and daughters conditional on being born, and this in itself can have an important impact on mortality.
That's part of the missing 5 million.
That would be part of the missing 5 million. That's not what we are looking at. And indeed, if you don't declare the birth of the daughter that died after birth, that's a bias, basically. So we don't look into that, but that's something that exists. Also, thinking about bias, but once again, that's really not what we're dealing with. By experience, I can tell you that also people tend to forget about their daughters when they declare in the data more than that of their sons. So it's not that they are dead, it's just that, for example, if you look at declaration of, what is the history of marriages of your son versus the history of marriages of your daughters, well, numbers don't add up. You have more information on the number of marriage of sons than you have on the number of marriage of daughters. So there is also this, but we cannot, we don't look into that. But this exists. Yeah. And so those, so what do we want to do in this project? So basically, we want to be looking at those questions of gender preference linked fertility practices at the world level. And so we want to know in which societies these are taking place, where, which societies, when, but we also want to quantify them. So how many children really are concerned, how does it evolve over time, etc. And so in practice, this leads to issues of measurement, statistical issues. How do you do it properly? So obviously, this is a very important question, and we're not the first ones to look at it. Demographers, for example, have been working on those questions for decades, sociologists, historians, and economists. And so there are already many tools, statistical tools that aim at detecting the practice of stopping rule, which I will write SR, and sex-selective abortion, which I will write SSA for short. The most obvious measure of the stopping rule is to look at the sex ratio of the last born. So why is that the most obvious way of doing it? It's because by definition, if everybody in a society is practicing the stopping rule, that means exactly all the last born will be boys. And so if you look at the gender ratio of the last born, if you see that it's 100% boys, you know that everybody is practicing the stopping rule for sure. Another way to look at it is the parity progression ratio, which is the same idea, which is to look at whether the last born is a boy or not, but it's a bit more subtle because what people do is that they look at basically at each rank the probability to have younger siblings, whether you're a boy or a girl. So it's basically if I'm a boy, am I going to get younger siblings? If I'm a girl, am I going to have younger siblings? That is, if I'm a girl, what is the probability that I'm the last boy of the family? If I'm a boy, what is the probability that I'm the last boy or the last born of the family? For the sex-selective abortion, then sex-selective abortion, what it is, it's an artificial way of changing the sex ratio at birth. So because now, once again, if everybody practices sex-selective abortion, you will have 100% of boys that are born. And so the idea is that if you look at the sex ratio at birth, you know that it's not natural to have 100% boys born. The issue with those measures is that you need to compare them to a natural sex ratio. For example, for sex-selective abortion, what is a sex ratio that is abnormal? Obviously, if it's 100% of the births that are boys, you know that something is going on. But in practice, not everybody is practicing sex-selective abortion, and not always. So you need to compare it to a natural sex ratio. What would have been the natural sex ratio at birth in the absence of sex-selective abortion? And it turns out that there is no, we don't know what the natural sex ratio is for each society in the world over time. So it's estimated to be between 130 and 107. So, and that's quite a large window. It's basically between 50.7% of boys being born versus 51.7% of boys being born. So yeah, that's quite a large window. And in fact, if you look, you have a bit less than 60 in our data, a bit less of 60% of countries that have a sex ratio between 103 and 107, which means that you don't really know whether this sex ratio that you're observing in those countries, is it a suspicious sex ratio or not? And this may also change over time and space. So what we're going to try to get around this issue. So as I was saying, many people have been working on the stopping rule, and there are theories of the stopping rule. And typically, the approach that has been taken when people have been thinking of the stopping rule.
So we have a question online from Mela Cyril Fodabong, and I would like to add mine. The question from Mela Cyril is, can the higher number of males at birth be explained by sex-selective abortion? And my question is, how did you define the 103, 107? Is it like a 2/3 interval, like plus or minus one standard error? Which case it's normal that you have about 60% of the countries in that range. So, two questions. How much can you explain these data from sex-selective abortion? And secondly, how did you define the two numbers?
So for the first question, so we're going to try to answer that in the paper. So we're going to try to tell you what is the share of births that are due to sex-selective abortion. So we'll come to that by the end of the talk. And to answer your question, Michael, we're not defining those thresholds. This is what the literature has found.
Yeah, but is it?
No, it's not a statistical definition. It's what people think looks like a natural sex ratio in different societies.
So you would expect 100% of the countries to be between these two numbers?
If all societies had the same natural sex ratio, yes.
Okay,
It's a bit of a circular reasoning there.
Exactly.
Is there medical evidence to expect a national ratio? Shouldn't it be 50-50? Or is nature calling in an evolutionary way for more boys or girls?
So what is known is that there are more birth of boys than of girls, because boys tend to die more in the first. So with equal treatment, etc., boys tend to die a bit more. So then at birth are more boys, and then it equalizes.
That's the evolutionary.
And then so that's what I think is a consensus of in the literature. But then we don't know what is this exact number. And it's not clear whether that actually is an exact number. Okay, so when people have been thinking of the stopping rule, they've taken the approach of the entire family. So they've been thinking of, okay, what would entire family look like if they practice the stopping rule? And they've been relying on the natural sex ratio at birth. And so as I'll show you, this leads to complicated modelization, and that may lead to misinterpretation, and hopefully we'll do a bit better. So that just to show you a bit what the models look like. That's a very important study on the stopping rule by Sheps in 63, published in Population Studies. And when you look at the entire family, it's very difficult to model it properly, and so you end up having this very big table saying, okay, if the family wants one boy but no girls, how will the fertility look like? If they want two girls, one girl, etc. So it becomes basically very complicated. In 2010, there is this influential publication in demography by Basu and de Jong, which basically gives you the same type of modeling. And so that's very complex to play with. And this leads to misinterpretation, like taking this entire family approach. For example, Basu and de Jong write that according to them, the stopping rule leads to two implications in terms of fertility behavior. One, which is that girls will be born into larger families. And this is, so they call that the sibling effect, and we'll show you that this is wrong. And then second, that girls are born earlier within families, which is true. And so this Basu and de Jong is a generalization of also an important paper by Yamaguchi in 1989 in demography. So this first implication is wrong, and the reason why it's wrong is because they take this family level approach, which prevents them from seeing that girls are born in exactly the same families at birth, exactly as boys, sorry, but it's after their birth that things have changed. And so what we do is that instead of looking at the family, we look at the child. We look at the child level, and then that makes things, you see, super easy. So easy that I was able to do it, and I'm really bad at theory. So you'll see. And so our intuition is basically that with the stopping rule, girls will have more younger siblings than boys. It's not that they're going to have more siblings in general. The reason why they will have more siblings in general, it's because they're going to have more younger siblings. So girls are not born in larger families, as Basu and de Jong think. No, they are born in the same families, but after their family become larger. And the two implications of Basu and de Jong, which is that families are larger and girls have a higher birth order, is in fact one thing, which is that girls have more younger siblings than boys. And so we develop a measure around that idea, basically. And the great thing, we think, of this approach is that you don't need to rely on the natural sex ratio anymore, because you just need to compare, okay, do boys have more younger siblings than girls? And you don't need the natural sex ratio anymore. And so Yamaguchi in 1989 saw already that girls will have more siblings than boys under the stopping rule, and got a little bit decided that you could use it to detect stopping rule, but did not see that it was only the younger siblings. In the second half of the talk, we'll speak about sex-selective abortion. I'm not going into as much depth about in the sex-selective abortion literature. It's more empirical than the stopping rule literature. So, for example, Malhotra and Cochrane have this paper on India looking at the access to these novel technologies that allows you to know the gender of your child, how much it affects sex ratio in India. Dimri and co-authors look at how many women are practicing sex-selective abortion in India. And most studies basically look at the sex ratio at birth. And I'm not giving you now the intuition of our approach because it's a bit less intuitive than the stopping rule, so we'll get to that a bit later in the talk. But once again, it's going to be the same idea that we're going to take the perspective of the child rather than that of the family. And whereas for the stopping rule, we are looking at what's happening after the birth of the child. For sex-selective abortion, we are going to look at what's happening before the birth of that child. And with the idea that with this sex-selective, in a world where people practice sex-selective abortion, girls will have more boys than girls among their elder siblings. And so I'll give you more intuition about that later on. But once again, you don't need to rely on sex ratio at birth to identify it. And so we hope that with this approach that doesn't rely on the natural sex ratio, we can better detect sex-selective abortion and stopping rule, in particular for those countries that are in between 103 and 107. And so that allows to help focus attention on countries that have been understudied for those in those dimensions. So just to give you an idea, so here in this graph, each dot is one country that we have in our study. So in the x-axis, you have the proportion of boys among last born. So you're trying to detect the stopping rule, and you look at the proportion of boys among last born. And on the y-axis, you have our measure of the stopping rule. So you see, obviously, there is a strong correlation between the two because we're measuring the same phenomena. But in these two, 103, 107, well, those are cases that are ambiguous. You don't know. For here, well, with the proportion of boys among last born, you don't know what to say. Whereas our approach will allow to disentangle those cases.
Guilhem, can I ask a question, Gani, here?
Yes, of course.
So related to what you said just before, when you compared the two approaches, I wanted to ask a clarifying question. Is this simpler and nicer approach that you are going after has to do with the fact that the decisions are made sequentially once you realize the sex of the previous child and so on, instead of family planning exactly from the very beginning when the couple is formed? I mean, I understand there's something very intuitive in the fact is that the decisions can be updated and changed as things go along. And I think that's how, an economist would think about it, rather than saying you decide once and for all from the very beginning, and that's and therefore you plan essentially multiple decisions from the very beginning. So that doesn't seem to be very intuitive, and that might be also the reason why they have such a complex approach to it, no?
Yeah, I think it's a very smart way of presenting it. We didn't think of presenting it like this, but indeed you can think, as you were saying, that those decisions are made sequentially, and so you adjust basically your decision as a function of basically the birth that you have had before. And indeed, it's not intuitive for us as economists, but when you are interested on the question of the consequences of, for example, the stopping rule on fertility in general, then it becomes natural to think at the family level. Because the way people have been approaching this question is they were interested in, okay, do people tend to have more children that they would have liked because of the stopping rule? And so that's why they have been taking this family level approach rather than the child level approach, because that's more direct in a way. I don't know if that answers your question.
Yes, to some extent. It's just I think one thing which I understood from your approach, from your explanation, is that the appealing aspect of that is that you have the possibility to change your if you had an initial strategy. The approach that was advocated by the previous author, my understanding was that it just assumed that you made the decision from the very beginning and you have a kind of plan, contingent plan, okay? Instead, yours is saying is that we decide as things go along and we update essentially our next decision as some uncertainty gets realized. And that to me is more intuitive. So I don't know if that's the right way of presenting it.
No, so what has been done in the literature typically is, so people have preferences. So, we want 2 boys. And then write down the probabilities that you're going, if you want those 2 boys, how many more births are you going to need to have those 2 boys, basically. And so they, okay, what happens if you want 2 boys and a girl, 3 boys, etc. And they write all the combination possible, and that makes it very burdensome. So in a way, that's also what we are doing. It's just that we don't need to go into these details of how many exactly, how many boys, how many girls do you want, because everything is so much simplified when you look at the level of the children, of the child.
Okay, thank you.
And we have Matthias who wants to also ask a question.
Hello, maybe a follow-up question to Ganis. Well, first of all, I guess unless there are some elements of time inconsistent preferences, I would think that if this is seen as is the family seen as a single decision unit, you can always present this as a time consistent plan from the start. And in fact, by the way, with abortion, if you decide, okay, I will have abortions for girls after a given number of girls. I mean, it's even reasonably simple, no? But now maybe I'm missing something, but I thought that, as I say, in the absence of time inconsistent preferences and strategic interaction, you can always present this as a time consistent contingent plan.
Yeah, so for us, it's time consistent. It's you have a plan, which is you want X number of boys, and this number of boys is going to be larger than girls. This is fixed. Those are your preferences. But in practice, because so in the absence of sex-selective abortion, you don't know what birth you're going to have. Is it going to be a boy or a girl? And so basically, this will affect your behavior. But the preferences remain. So in expectation, if you will, things are fixed. But at the individual level, you don't know what draw you're going to get. So maybe we can go back to this question once I present the way we approach this question.
Okay. Thank you.
Thank you. So that's for the stop.
From what I hear, the big difference is simply the information you get along the way. About the 2 approaches.
And so that's for sex-selective abortion. So we have our measure of sex-selective abortion and what we would typically use to detect sex-selective abortion, which is sex ratio at birth, not sex ratio in the last born. And so once again, you see that you have this big window of almost 60% of ambiguous case. Let me tell you one thing of those 2 graphs with colors that I've shown you here. I'll come back to them later because here for intuition, I just made it very simple where in between these brackets, it's ambiguous and outside it's not. But in practice, the moment you add confidence interval, things become a bit more complex, and I'll come back to that later. So let's move to the stopping rule. So as I was saying, the literature focuses on family level outcome, total number of children, sex of the last child, total number of siblings per gender, etc. The way we view it is we take the perspective of one child and the stopping rule as a lottery. So the family, they want to have a certain number of boys, B star. And so they're going to have children. So in that world, there is no sex-selective abortion. They're going to have children in order to get the number of boys that they want. So every time there is a pregnancy and a birth, it's a draw in that lottery. Do I win? I have a boy. Do I lose? I have a girl. And then when you think along those lines and you look at what is a fertility trajectory if a girl is drawn rather than a boy. And so if you take 2 families that have exactly the same preferences, they want exactly the same number of boys, the same number of girls, and they have their children, and they arrive at the birth order K. At birth order K, there is one family that gets a boy, and that is that boy allows them to reach the number of boys that they wanted, so they stop having children, they reach the number that they want. The other family that had the exact same gender composition in previous births has a girl. And so they are missing one boy to reach the number of sons that they want, so they continue They continue once. Is it a boy or a girl? If it's a girl, they continue, they continue, they continue. And so they continue, if you can have an infinite number of children, they continue, if they are very unlucky, up to infinity. And
you're not putting any value at the number of children in general, only boys.
As a
so here you want only boys. It's the same thing basically.
No, I hear the way you describe it. If I have already 10 children, the logic of going further is the same as if I had only 2.
In this very simplified case, yes. So in that world where there is no maximum number of children, the only thing that matters is that you want this number of boys. Well, in that world, a girl will have on average 1/p with p the probability to have a boy, more younger siblings than a boy. So if it's 50%, girls on average will have 2 younger siblings more than boys. So obviously, so that's similar in spirit to Yamaguchi 89, who saw that girls will have 2 more siblings under the stopping rule, but not younger siblings. Obviously, people cannot have an infinite number of children, so they may have a maximum number of children. In that case, the girls will not have 2 more younger siblings, but they will have more younger siblings. You cannot know how much exactly. And something that is also happening a lot in the real life is not so much that parents have a maximum number of children and they will stop. They have an ideal number of children, but they are willing to accept to go a bit further to get the number of boys that they want. So they have lexicographic preferences. They want a number of children, but it's more important for them to reach their number of sons. And so even in that world, girls will have more younger siblings than boys, but in a world where demographic transition is happening, so people want less and less children, well, the stopping rule will become more and more binding, because typically, if you are going to have 10 children anyways, and what you want is 2 boys, the moment you reach 10 children, you are going to have those 2 boys. But now if you want only 2 children, when you reach 2 children, it's very likely that you will not, or it's much less likely that you will not have had 2 boys in those 2 births, and so you will be implementing the stopping.
So, Guilhem, again, Gani here. So, concerning this last point, very interesting. I think this is probably like very intuitive. So, would this imply that in the extreme form of it, think of the China's one-child policy, this is where you would expect a very strong bind on sex ratio and therefore massive sex-selective abortion?
So here, right now in this model, there is no sex-selective abortion. So in the case of the one-child policy where you are allowed only 1 child, then in that world there is no stopping rule and there is no sex-selective abortion because you don't control your fertility in a sense. The only choice you have is to have 0 or 1. So, but if you have access to, if you can have 2 children, then what you will see is that you want 1 children, but you can have 2. You will see that basically the only families that have 2 children are families whose firstborn is going to be a daughter. Those families are going to be bound by the stopping rule, whereas the family who already got their boys are not bound because they got lucky in the lottery draw. And of course, if you can have access to sex-selective abortion, you will see that you use sex-selective abortion much earlier in the birth order. And so just looking at the data, so here this is Indian data. So India is known to be a society in which there is strong son preference and practice of the stopping rule as well as practice of sex-selective abortion. So here in this graph, so we use Indian DHS data from 2015 where we have information on the birth history of mothers. And so we look at each child in this data at different age. So when this child is -2, -1, 0, the year of its birth, 1, 2, 3, up to 5 years old. And we look at the number of siblings of that child when that child is -2 and -1. When that child is -2 and -1, the number of siblings is the number older siblings, because the child itself is not born. And after he's born, so after 0 and 1 year old, it's the total number of siblings, including older and younger siblings. And so what you see is that between male and, so this is just the mean, those are like pure descriptive statistics. Before the birth of children, there are no difference in the number of siblings between boys and girls, but it's only after the birth, so when children begin to have younger siblings, that you see a divergence between male and female. So this is to illustrate our idea that basically the only thing that matters in the stopping rule is what happens after the birth. And so you see that girls start having more younger siblings than boys. So that's really the idea that we're going to use to identify those stopping rule countries in which the stopping rule is binding. So as I was saying, there are several measures that has been used, and that are typically used. I'm not going to be describing them again because I've discussed them already. But what we're going to do to avoid relying on a natural sex ratio that we don't know, we are just looking at the average difference of younger siblings across gender. What is the average difference, the average number of younger siblings of a girl versus the average number of younger siblings of a boy? Is there a difference? And that's what we're going to use to detect the practice of the stopping rule in different countries. So we use basically all the countries for which there is data in the demographic and health survey. So that's 82 countries in which women aged 15 to 45 are asked, so that's 1.3 million mothers, are asked about their 4 million births.
So these are the points you had on the previous graphs, these 82 countries.
Yeah, exactly. And so, as in the graph that I've just shown you, we're going to be looking at the child age level. So each child is observed 8 times at age -2 to age 5. And obviously, we restrict to children that are born at least 5 years before the survey, so that they have reached this age 5. And so what we do is that we regress. So in the first, here to really convince you again that it's the number of younger siblings rather than the number of siblings, first we regress the total number of siblings on the age of the children and the age and whether that child is a girl. Okay? And we do that for all countries, basically. And so once again, taking the example of India, so here this is basically the same graph as before, but in a regression form rather than just taking the descriptive statistic. So you see that a girl in India, prior to her birth, has the same number of siblings than a boy. But the moment she is born, you see this strong divergence. She starts having more siblings than boys. This is true for India. This is not true for Zimbabwe, in which, and so according to us, there is no stopping rule in Zimbabwe, and it's well known that there is a stopping rule in India. And so I think now it's quite convincing that it's only the younger siblings that matter. So from now on, I'm not going to be talking about the total number of siblings, but really about the number of younger siblings. So now to identify in which country the stopping rule is put in place, basically we look at the last coefficient of this regression at age 5. We do this regression, so here for India, for Zimbabwe, but for the 82 countries in our data set separately. So we do 82 regression, and we look at this last coefficient of the difference in younger siblings between boys and girls in those countries. Yes?
So if I see the confidence intervals, can I interpret that in India it's so systematic that everybody behaves the same, and that's why you have these very narrow confidence intervals? In Zimbabwe,
no.
It's pretty random.
It's because sample size are very, very different.
It's just
India 2015 is really a massive sample, whereas Zimbabwe is much, much smaller.
Okay.
And so these are the results for all the countries in our data set. Those are ranked. So those are the beta 5 of those regressions. So the difference in the average difference in the number of younger siblings between boys and girls, country by country. And so we rank them from the smaller to the largest. And so the colors are basically regional areas. And so in this, you can see, if you have very good eyes, the name of the countries as well in the x-axis. And so on the right-hand side, you will see the countries that are practicing the stopping rule against girls, but you may have noticed that, in fact, our measure is gender neutral. So I've been motivating it in terms of discrimination against girls, because that's what's happening, in the vast majority of cases. But you can see also on the left-hand side that you have a few countries which would be classified as practicing the stopping rule against boys. And so what you have on the right-hand side, so you have countries in which it is well known that the stopping rule is being practiced, like India, Nepal. But you also have areas that are much less studied, that, for example, India, like countries from Central Asia, typically. You have Azerbaijan, you have Tajikistan, etc. in this group here. So so in terms of detection, that's where we are. So we find that the stopping rule is prevalent in the countries that we know where it's prevalent, but also in countries that are a bit less studied along that line. We uncover that there may be a stopping rule against boys in certain societies as well. So how do we, so is it useful, basically, this measure? So remember this graph? So we have, for the stopping rule, 36% of ambiguous cases, so those cases that are in between. So as I was telling you, in fact, you need, the moment you take into account confidence intervals, the picture is not as clear-cut, because you can be outside this bound but not be statistically different from something that is in this bound, or you can be inside this bound and not be statistically different from any of those differences. So that's the real picture. And so those 30% of ambiguous cases, these are those ones.
And couldn't you pool some of these countries that are similar then to have better estimates? Because you showed on the previous graph that you had a number of countries from the same region.
Yeah.
They were one next to the other. So could you treat them as one country?
So the issue here is, so you mean in terms of statistical significativity? Yeah. So we could. So that would not help here, because here it's there is the statistical significance to which I'm referring to, and I wasn't clear. Is that related to the proportion of boys among last born? And so if we would know that two countries have the same natural sex ratio, but we would have ground to.
Can you go back to the one with the colors? So different countries, one next to
this one.
Yes. So I see in the middle, and so this is in the ambiguous part, Gambia, Togo.
Okay, sorry, I understand.
So if you pull them together, they're one next to the other, about the same.
Okay, so I see what you're. Okay. So here, this is our measure, which is, do we see that girls and boys have a different number of younger siblings? And so here, and we emphasize it in the paper, what you can interpret out of that, it's whether it's positive, negative, and whether it's significant. But the level itself is quite difficult to interpret, because it's a function of basically the preferences of in the society, which we don't know. We don't know what people want to do.
Expect that if they share a common history or the
so yeah, we could
then you can make a guess that you can pull two countries together and narrow down the confidence interval.
So we could do something like that, like saying, okay, those two countries are very similar culturally, but they have small sample size. Let's just put them together. Yeah, that's something that is feasible.
Thank you.
And you could do it the other way as well. If you have for example, a very big country like India, you could say, well, the north of India really has a very different practice than the south, and that's basically you can organize the sample the way you want. Yes.
Could you go back one slide, please? No, I think it's
this one.
Back one slide. No, then it's up one slide.
Further
down. Yeah.
After the stuff you just showed us.
Yeah.
Okay. This here?
Yeah. Here. Going back to the problem of the natural rate, I mean, it seems to me that your findings are relatively strong, and that even if you would redo the exercise, and work instead of between 103 and 107, work with, let's say, 98 and 112, that you would still be very confident in your findings. So that's a way of saying the natural rate doesn't really matter.
Okay. So yeah, in our approach, it doesn't matter at all.
Yeah. So you prove that in a way.
Yeah. It doesn't matter at all. But here, those are credible natural sex ratio, and so yeah, I don't think we have ground to make them larger because nowhere in the literature people.
Well, but even if you would have to.
Yeah,
you could still be on safe ground.
Yeah, it's for us. It doesn't change anything. Yeah. And so now, if you look at those cases that are ambiguous, like it's a selection of those countries that were in red in the previous slide. So basically, out of those, we solved basically 37% thanks to our measure. And so basically, most of them we classify, those that we classify as a stopping rule against female. There are a couple that we classify as a stopping rule against male. So here in this graph, those confidence intervals are the confidence intervals that relate to the sex ratio of the last born. Those are not the confidence interval of our measure. So you see that basically all those confidence intervals are overlapping with one of the definition of the natural sex ratio. So those are the cases that are ambiguous from the perspective of the sex ratio of the last born. And those for which we have put colors in either red or blue, we are able to disentangle thanks to our approach. Okay, and so that's just pure detection. And so we think we do a bit better than the previous measures. But what we want to do now, so we know in which countries the stopping rule is taking place. Now we want to quantify how many children are really affected by that. And so in our perspective, so once again, taking the case where people don't want girls, the only reason why you have a girl in that world is because you want to have a boy. And so, but in ex ante, because you know that you're going to be practicing the stopping rule, in a way you want to have that girl. Your objective is to have the boy, and so you accept to have a certain number of girls in order to get that boy. So it's just that those girls are going to be instrumental. You use those girls to attain a certain number of boys. So that's why, in that perspective, we're not saying that you don't want those girls. We're saying that they are instrumental. Ex ante, in a way, you want them. Ex post, you don't want them. I don't know if that's clear. We have a debate with my co-author about this. You don't agree, for example.
I have to think about it.
Yeah, okay. I'm happy to discuss. We're discussing exactly this with my co-authors as well.
We have a question from Mela Cyril about the connection between this and selective and abortion. Yes.
Yeah. All right. Thank you very much for this presentation. I very much enjoy it. But I just have a question. I want to ask you whether this sex-selective abortion is really something we should worry about. What is it really a public health issue? What is the burden of this problem? And my question is based on the fact that for us to talk about sex-selective abortion, the sex of the baby must be known early enough for the baby to be aborted. And in most countries, women tend to start ANC late. They start in the second trimester and they do ultrasound to know this. And if the sex is late to abort the baby. And even in countries where they have technology to determine the sex of this baby early enough, it is expensive to know the sex early enough just for you to abort the baby in the end. So it's difficult to get the sex of the baby early enough in most places for abortion to be done. So is this really a problem? Thank you.
Well, so I agree with you that you need basically this technology to be able to implement sex-selective abortion. And basically answering this question is what we are after when we go to the sex-selective abortion part. And for example, in the case of India, I'll show you that it's an important part. But it's not the case for all countries, that's right. All right. So now, staying on the stopping rule. So how many of those girls are instrumental, are born just because their parents want boys? And so here, moving out of the detection towards the quantification, so here we will make assumptions about the natural sex ratio and about the structure of preferences. And for the illustration, I'm taking only the Indian data of the Indian NFHS round for 92, 98, 2005, and 2015, so that's close to 2 million births. So here, in terms of assumption, we can take either the upper bound or the lower bound of natural sex ratio, and we assume that, so that's not a strong assumption at this point, because this is going to give us bound, basically, of the number of instrumental daughters. What is a strong assumption is we are assuming here in that quantification exercise that no girls are desired. So parents want boys and only boys and no girls. So that's a very strong assumption because there is evidence that parents want one girl. And so the thing is that if you, at this stage, that's where we are basically, but if you allow the number of desired girls to be positive, then computationally it becomes very complicated. So, and so basically that gives us an upper bound on the share of instrumental daughters. And how do we compute it? So basically we take this beta 5 coefficient and we multiply it by P, the natural sex ratio that allows us to know the proportion of girls. So in India, on average throughout the period, it's going to be roughly 13% of girls that are instrumental. And you can look at the evolution over time, and you see that throughout the 90s to the early 2000s, it's roughly 50%, and then it strongly decreases in the 2000s. And then this raises the question, what's happening? What's happening? And people that know the Indian context will suspect that this is because sex-selective abortion becomes widespread in India. It starts in the 90s and becomes really, really widespread in the 2000s. And so the moment you can choose basically the gender of your children, you don't need to be using the stopping rule as a way to select, to reach the number of sons that you want. And so that allows me to make the transition to, if I manage, to the question of sex-selective abortion. So here, how do we detect now sex-selective abortion? Same idea as with the stopping rule. We take the approach of looking at the child rather than the family. And here, instead of looking at the younger siblings of the children, we're going to look at the elder siblings. And we're going to, basically, we show that under sex-selective abortion, when you're born and you're a girl, you're going to have a larger share of boys among your elder than if you're born and you're a boy. And so, basically, once again, we're going to be compared to detect places in which sex-selective abortion is being implemented. We're going to be comparing the share of boys among elder siblings of girls as the share of boys among elder siblings of girls, and look at the difference. And so you don't need to rely on the natural sex ratio for that, because no matter the natural sex ratio, whether you're a boy or a girl, you should have the same gender composition of your elder siblings if there is no sex-selective abortion.
To take a simple case, I look at the second child, and I'm now looking at the gender ratio of the first. And before that, you were doing the third one.
Exactly. And so basically, yes. So basically, the idea is, if the first child is a boy, you are less likely to use sex-selective abortion for the second child, and therefore you have a good chance to have a girl in the second child. Whereas if the first child is a girl, you're likely to be using sex-selective abortion for the second child.
Okay, you're still looking at the next one.
No, we're looking at
yeah, you take the first, and you look at the next.
So from the perspective of the parents, you have a boy, so you don't, and there is a cost to sex-selective abortion, so you don't use sex-selective abortion next. At the second birth, because
you look at the gender of the second one, conditional on the gender of the first.
No, now that the births are realized, you look at the second, and you see that, okay, that's a girl. The girls that are born are going to have more boys in their elder siblings.
Oh, okay. Yes, okay, that's what, sorry, it was correct. Yes.
Just for clarification, are we saying that, and in this case it's SSH, and previous it was SR, that if we have SSA then girls have more boys than girls among elder siblings? Or do we say that if girls have more boys than girls among elder siblings, then we find SSA? Or do we say, well, it's an if and only if?
No, it's if and only if. So basically,
if and only
if there is no sex-selective abortion, the gender composition of the elder should be the same. I mean, if you think about it, so if there is no sex-selective abortion, a parent can't control the gender of their children. So at the rank K, so basically the probability of a child to have a to be of either gender is independent of the distribution of genders before. So then that's it. Okay, so the framework is you can have a maximum number of children, and you want, again, a certain number of boys among those children, and there is some probability that the boy is born, and there is a cost to abortion, which is C, and we assume that the sex-selective abortion really perfectly selects the gender of the child. And so, because there is a cost to have an abortion, and there is this maximum number of children that you want to have, sex-selective abortion will start first for families that only had daughters in their first birth, and then they reach the moment where if they don't use sex-selective abortion, they know that they will have a probability not to get their desired number of sons. And then they will start implementing basically sex-selective abortion at the rank n minus b star plus 1, which is the last birth. If they want, I don't know how to explain it clearly. If they want two boys and they have only two births remaining, this is the moment when they start implementing sex-selective abortion. So they delay as much as they can. And then the moment you start implementing sex-selective abortion, you don't stop. Basically, for those families that have only daughters in their first birth, and so that's true at each rank. And so basically, that means that at each rank, sex-selective abortion, K above this level, sex-selective abortion is applied for a proportion of boys in that rank. And so that means that for those boys for which sex-selective abortion has been implemented, there is a large proportion of girls in their elder siblings. And so that's our proposition. Under sex-selective abortion, from a certain rank onward, the proportion of girls among elder siblings is larger for boys than the girl, and so that's true at every rank. Okay, and so we use that to detect sex-selective abortion. So we use the same data set as before. We use basically again this child level data, but here because of the comment that was being made, basically, which is the technology of sex-selective abortion was not always available, and so we just look at children born after 95, which is when the technology becomes widespread in certain countries at least. And so here, what we look at is the share of elder girls regressed on, are you a female or not? That, as simple as that. And so here is the same type of graph as before. And here you see that what is the differential share in elder girls across different countries, and that allows us to say, okay, in that specific country, it looks like sex-selective abortion is being practiced by a sufficient number of families so that we can detect it statistically. And so here, the country that seems to be, practicing sex-selective abortion a lot are Ukraine, Azerbaijan, Armenia. So you find again India, in which we know that sex-selective abortion is being practiced, but also many more countries that tend to be understudied, or at least understudied by economists.
And can you draw this graph over time?
Yeah, we come to that now. So, before I go to the evolution over time, so here is the case. So the same graph with ambiguous case, which is not the correct one because it doesn't account for the confidence interval. The moment you use the confidence interval, these are the 58% of ambiguous cases in our data, cases in which you look at basically the probability to have a boy, and you can't really say whether it's statistically different from one of the natural sex ratio thresholds. And so you see the correlation with our measure is important. And how many of these do we disentangle? So we disentangle 18% of these, and this time always against the women. We don't find a practice of sex-selective abortion that would be to the benefit of female. It's always an objective to get male, not to get females. So we solve, we make non-ambiguous, close to 20% of those ambiguous cases with our method. And now to answer.
Sorry, going back, I see, for instance, Côte d'Ivoire is significant now. Right?
So sorry, yes. So I should spend more time on. So I should spend more time on this graph. Sorry. So here, those confidence intervals are misleading, and I should explain this graph a bit better. So. Remember, there are two measures. There is well, in fact, the title is wrong. It's not sex ratio of the last born, it's sex ratio. In that case, the sex selective abortion is all births. So two measures: sex ratio at birth, and our measure, which is the difference in the share of girls among your adults. So there are two confidence intervals. Basically, the one when you look at sex ratio, and the one when you look at our measure. Here in this graph, we have just shown you the confidence interval for sex ratio. So if you want the confidence interval for the previous measure, this is to show you the cases that are ambiguous from the perspective of the sex ratio. But in color,
there's still, no, you know that there is sex-selective abortion.
Yeah, in color, basically, that's where basically our measure, if you want, is statistically significant.
So here's my question. Côte d'Ivoire, I expect fewer parents have access to ultrasound and actual abortion.
Yeah.
But it's in red. Turkey is more advanced, so I expect that more people who have access to the technology, and it's not significant. Right?
Yeah.
So you're saying that Côte d'Ivoire is actually using a technology that is probably not available, whereas in Turkey, they're not using a technology which should be available.
Well, okay, you think comparing those two people, yeah. So no, yeah, we're saying we don't know whether. In fact, we don't know whether this technology is more available in Côte d'Ivoire or in Turkey. One thing that yeah. So I don't know how to answer that. We'll just say yes. That's what we find. So because it's a matter of technology and it's a matter of willingness to use that technology as well.
But what would be the fraction of families who can actually have an ultrasound in Côte d'Ivoire? And therefore have the information.
Well, I don't know this. I can look at the.
My prejudice is that it should be pretty low. And I expect that in Turkey, every woman would go to the hospital, or almost every woman would go to the hospital and have an ultrasound.
Yeah, but then
the information is there in Turkey.
Do they practice sex-selective abortion?
No, we agree on that. It's just having a necessary condition to do something which is actual abortion is to have the ultrasound.
Okay, yeah. So here, okay. So I don't know. I cannot answer really for every single country. I don't know. But the approach that we take is statistical. So statistically, I'm telling you, Côte d'Ivoire is a suspect and Turkey is not. But that relies on statistical significance.
Yes.
So it could be that for the specific case of Côte d'Ivoire, it's statistically significant at the 5% level, but you have more than 20 coefficients here. So you're going to have coefficients that are statistically significant.
Yes, 5% of them.
Yeah, because there's just a large number of regressions. So it could be the case for Côte d'Ivoire also, and that's also an issue with statistical significance. It's a function of the size of the sample. So you could have a country which is practicing sex-selective abortion, but it's going to have a large confidence interval, and so we're not going to be able to tell you that with our measure we can detect sex-selective abortion. So that's an issue with basically any measure that uses statistical tools. And so to answer your question, Michael, on the evolution over time, so basically you can compute the same measure. You can compute it the way you want. You can compute it by age cohorts of children, age cohorts of mothers, and if you do it for by age cohort of children. So here again for India and Zimbabwe, you see that in the 80s, basically there is no difference between boys and girls, and then it started diverging in the 90s, and it is well known that the use of sex-selective abortion starts in the 90s in India, whereas in Zimbabwe, nothing seems to be happening. And then, okay, that's detection, and so now we try to quantify sex-selective abortion. So what is the share of children that should have been the other gender, basically, absent sex-selective abortion? And so once again, for the quantification exercise, we need to make an assumption about the natural sex ratio that we can bound if we want, and we illustrate it with Indian data. And so here, basically, we can calculate the share of unborn daughters, so those daughters that are boys, basically, because of sex-selective abortion. So there has been a pregnancy that has been terminated and replaced, if you will, by a boy, by the birth of a boy later on. And so we can compute how many of those are in India and over time. And so here, so here we see, here's the natural sex ratio that we use is the one that is in the data. And so in a future version, we're going to be using 103 and 107. According to this measure, you see that roughly during that period, you have 2.6% of daughters that are unborn that should have been born. And this is obviously increasing in the 90s. And so throughout the 2000, we're close to 3 to 4% of births, basically. So that's quite an important share of births. And so now I think I'm quite late. I don't know what time is it, but
so we are on time.
Well, okay, I'm surprised, but that's good news. So I'm going to conclude. So we've developed these two measures of detection of those fertility practices that are linked to gender preference. Stopping rule and sex-selective abortion, and by taking the perspective of the child rather than that of the family, we do not need to rely on the natural sex ratio anymore, and that allows us to identify societies that were ambiguous in terms of their practice of statistically ambiguous in terms of the practice of the stopping rule or the sex-selective abortion, and we're able to really disentangle quite a large share of those cases thanks to our measures. And in our quantification exercise, we show that both the stopping rule and the sex-selective abortion, at least in the Indian case that I've shown you here, represent really widespread phenomena. So this was known already, but we can quantify it. We propose another way to quantify it. So we have this upper bound of 14% of instrumental daughters that we're going to refine in the next version of the paper. And for sex-selective abortion, from the 90s onwards, 3 to 4% of births seem to be affected by sex-selective abortion according to our approach. So that's my talk. So thank you very, very much for your comments and questions. And of course, if you have others, I'm happy to take them.
Thank you so much, Guilhem. We already have one question by Philippe Orgaon.
A question or a potential suggestion. It is clear that I think in the discussion that SR and SSA interact. Because there is a relationship. SSA can be seen as for countries where people have easy access to abortion, it can be used to mitigate the negative effects of the stopping rule, to cut the long series short of big families. So my suggestion would be is to look for that interaction term, and when you use or estimate the coefficients for SR, to add the SSA, which you calculated just as a dummy, but only in the interaction in the multiplicative term. Because you have the advantage here, probably to say, well, okay, we expect that sex selective abortion interacts for logical reasons with the stopping rule, unless, of course, in countries where, for ideological, legal, religious reasons, or not having the access to medical instruments, where there cannot be an interaction. And I think it might even strengthen your results, and it might explain why countries in the SR are to the right of your results, so to say, might be more to the left or in the center on SSA.
So yeah, I think you're right that, I mean, we really want to deepen this question of interaction, of stopping.
And it relates to the instrumentality of, the girls as well, of course.
So I completely agree. The difficulties that we have, and so ideally what we would want to show is something like our measure of stopping rule is decreasing when the measure of sex-selective abortion is increasing. We show that there is replacement of one by the other, basically, which is what is happening.
It doesn't have to be a linear relationship between, or it doesn't have to be a clear correlation. With an interaction term, you can even have areas where they positively interact next to areas where they negatively interact in a significant way.
Generally you're right that we want to think more of where we're a bit stuck is that our detection measures really we are hard to interpret. Their level are hard to interpret because they are a function of many things, and to interpret them you need to make assumptions about the preferences of parents. So that's why what we have in mind now, you tell me what you think, is for the quantification exercise, where we are telling you the share of instrumental daughters, the share of births, there we make a couple of assumptions about what parents want, what parents want and what they are doing. And what we are going towards too is basically trying to see whether there is an evolution, what is the correlation between the two basically. And so right now we put those two graphs separately, but I think you're right that we want to one way or the other put them together. What we would want to do also, I've given you the example of India only, but I think it would be interesting to do it at the world level, basically. So to compute it for every country, and then I will get it, which we haven't done so far because actually we thought it would be, this quantifying exercise would be very easy to do, but it took us quite a while, in fact, to understand what could be done and could not be done.
No, but I agree. But identifying a significant interaction term is not the same as how to explain that. That's the difficult part. But if you would find a significant interaction term, then you're forced to do something in order to be able to explain that interaction. And I think an interaction is broader than a correlation.
Okay, thank you. We try to think about how to do it. Thank you very much.
And you may even start with selective stopping rule, and then as you get to the limits, maximum number of children, you shift from SR to SSA. So I don't see additional questions online. It's time to ask them if you have them.
For those of you who are sure, you can send it to me by email.
So, Gani here. It's more of a reflection rather than a question. I'm trying to go back to essentially this comparison of perspectives. So if I understood well, one intuition that I got from this is that from the child's perspective, the uncertainty or randomness that he or she is facing is who are his or her elder siblings, right? With whom you find yourself already as those born before you. And that essentially puts you at a larger or less strain in terms of what will happen to you at birth or something like that, right? So even without thinking of sex-selective abortion before getting there, what I like about this perspective is that from the child's perspective, whether you are born into a family where they're already the son preference is largely satisfied or not, that's exactly the kind of a lottery you're facing, right? Is it how I understand?
Yes.
Okay, and then that I think is a key point, and that then has consequences on the sex-selective abortion and so on and so on. So that's essentially is the kind of the crux of the whole story.
Yes.
Okay. And then this again is related to the question of the sequentiality of the decision. It's a vague thought. I haven't yet fully crystallized it, but does this somehow might be related to the issue of the option value in investment? Somehow the idea is that when you are making, so somehow from the point of view, so when you gave this nice example in the beginning, saying, look, suppose you have a strict preference for having at least 2 sons, and then you know that your budget or possibilities or broader choice of number of trials you can try with is like 10. Okay, so you can go very far. So in that case, essentially, you are gradually deciding how stringent that, so how badly that preference is going against the reality, essentially, right? You're lucky that you're the first and the second are sons. You say fine, okay. Then I don't do any other controls on what will happen afterwards. Whatever comes. Okay. But if you were quote unquote unlucky as the family of having the first and the second as girls, then you start feeling that preference that you had is going against the reality very harshly. Or this is when you more and more going for the SSA. That's more or less the interpretation.
Yeah, exactly. It becomes binding, basically, your preference. So,
right, so the extent to which it's binding, it's sequential, it's over time.
Exactly, yeah. Okay. So that's why in terms of measure, we cannot measure whether people are willing to use the stopping rule or willing to use sex-selective abortion. We are just measuring people that actually use it.
Yeah. Revealed practices.
Yeah. So I think it's another way of formulating what you're saying.
Yeah, there's something very appealing in the whole thing. I'm just trying to see what is probably the easiest way to, because I can imagine demographers probably find it easily, but for an economist, how the question is, okay, so what kind of decision-making process we're talking about, and what are the moments in which this makes? Okay, anyway, thanks a lot.
Thank you very much for your comments, Gani.
I see another question from Mathias de Watripon.
Yeah.
Yes, hello. Thank you for this very interesting talk. One comment about a different but related topic. I know in a number of countries there is this preference for boys. I don't know whether there's any country with a preference for girls, but I do know that in countries like ours, there is, I mean, for some people, there is value of diversity. When people have 2 children, and you say, well, I have a boy and a girl, some people say, aha, le choix du roi, the choice of the king. Even though, by the way, kings typically need to produce males, but and there are people who keep going until there is some diversity. In fact, there is even a rule in Belgium, well, a custom, but I think it is enforced, that if you have had like only girls, 6 or 7, I don't know, then the queen is your godmother. And if you have only boys, but 6 or 7, then the king is the godfather. So, which indicates that some people keep going until they will get. So is there work on you know, the value, how important the value of diversity? I think it's, at least it's taboo in our countries to have self-selective abortion, but on the stopping rule, I think it's interesting, and maybe it's done, to look at this effect and whether you see it in the data.
So yes, so people have been using so basically here it's a stopping rule that is gender neutral that you are discussing. So you have preference for diversity. So you have two boys in your first birth, so you continue because you want to have a girl, you try to have a girl, or vice versa, you have two girls and you continue in order to have a boy. So that's a stopping rule that is gender neutral. And so people have been, so here we would not be able to detect it because we are looking really at gender imbalances. But people have been using that to instrument for fertility, basically. So, you know, if you have had the first two births of the same gender, so you're much more likely to get a third birth. And so people have been using that as an instrument for fertility, you know, to look at the effect of competition among siblings for education, and the effect of of having one additional child for women labor force participation and things like that.
Okay, thank you.
Thank you very much.
So thank you very much to Guilhem CASSAN for this fantastic presentation, and to Caroline Van Swieten for making it happen, and everything went so smoothly. Thank you so much. So I guess we can clap.
Thank you very much so I can't see you, but thank you very much for having attended online. I know it's a bit boring to attend seminars online, so thank you very much for having attended anyways. And thank you for having been here as well. Thank you very much.
Thank you.